exponential function with base a is defined for all real number x by the function f of x equal a to the exponent x, where a is greater than 0 and a is not 1. So let's take a look at the graph of the exponential function. Sketch the graph of the following exponential function, then state the domain and rank of the graph. So let's graph this by first making a table of value. We choose the value for x as follows: -2, -3, -2, -1, 0, 1, 2, and you can pick pretty much any other number you like because the exponential function with base a is defined for all real number x, which means x can be pretty much of any number that you like. Then f of x equal 2 to the x, so 2 to the -2 equal 1 over 2 square, make 1/4. 2 to the -1 equal 1 over 2 to the first, that is equal 1/2. 2 to the 0 equal 1, 2 to the first equal 2, 2 to the second equal 4. So then, let's plot this value: -2 1/4, -1.5, 0, 1, 1, 2, 2, 4. And so we get this is of the curve. F of x equal 2 to the x. So let's label this point 0, 1. This point here is 2, 4. And like I said, the exponential function with base a is defined for all real number x. This means the domain of the exponential function, the domain of f of x here, is from -infinity to +infinity. Looking at the graph, the range is on the y-axis. Note that this graph is go closer and closer to the x-axis, right? Move closer and closer to the x-axis, but never actually cross the x-axis. This means the range here is from 0 to infinity. So let's just think about this. Let's say you pick x to be a -1000. Let's say, let x equal -1000. Then f of x can be evaluated as 2 to the -1000. This is 1 divided by 2 to the 1000. This means 1 divided by a very large number. And this is still positive, right? And this is become very close to 0. Gotta go to 0. So as x get larger on the negative side, so as x approaches -infinity, f of x is approaches 0. As x approaches +infinity, f of x approaches infinity. So this telling us we have the horizontal asymptote. At x equal to 0. Right? So then the range is go from 0 to infinity. In the next case, f of x equal 1/2 to the exponent x. Let's pick the value for x and calculate the value for f of x. -2, -1, 0, 1, 2. So 1/2 to the -2 is equal 1 divided by 2 to the -2. That equal 2 to the second equal 4. Similarly, we get 2, 0, 1/2, and 1/4. So let's sketch this graph. 2, 1, 4, 1.5, 0, 1, -1, 2, -2, 4, So this is the graph of f of x equal to 1/2 to the x. Again, the domain here is from negative infinity to positive infinity. And as we can see, the range here go from 0 to infinity. And we have the horizontal asymptote at x equal to 0. So note that there's a key point in this two graph. 0, 1. This always one of the points in the graph of exponential function, of the standard exponential function, because when you take anything to the exponent 0, you get a value of 1. So something that you should note for the exponential function. For exponential function f of x equal a to the x, we always have the y-intercept at 0, 1. Okay, horizontal asymptote x equals 0. We have the domain negative infinity to infinity, and the range 0 to infinity. So this is the standard f of x equal a to the x. Let's talk about the graph of exponential function. So like I said, the exponential function f of x equal a to the x, where a is greater than 0 and a is not 1, have the domain from negative infinity to infinity. The line y equals 0 is the horizontal asymptote of f of x, and the graph of f of x is of the shape as in the picture. Oh, the line y equals 0 is the horizontal asymptote. So in the previous two problems, when I said x equal to 0, I really meant to say y equal to 0 here. Y equal to 0. Okay, so let's say we are given the graph and we want to find the exponential function. We want to find the function, okay? So we are given f of x equal a to the x. Okay, and in this first graph, we know that x is equal to, and f of x is equal to 25. Okay. So let's put it into the formulas. F of x equal a to the x. So 25 is equal a to the second. So here you can guess here would mean a is equal to 5, right? How do you determine whether x equal to 5 or negative 5 in this case? Remember, take a look at the shape of the graph. So if it goes from left to right, it increasing from left to right, therefore a is positive, so a equal, and a is greater than 0, and a equal 5 here in this case instead of 1/5 because the graph is increasing. So here, because we given an increasing graph. So then f of x is equal 5 to the x. So let's take a look at the next one. So here we get x is equal to 3. F of x is equal to 1/8. And we know it goes through the point 0, 1. So let's put it into our formula. This means 1/8 is equal a to the third. Okay. So if I take cube root from both sides, then this telling me a is equal to 1/2. Okay. So then f of x is equal 1/2 Again, this makes sense because we have a decreasing graph. Transformation of exponential function. Use the graph of f of x equal 2 to the x to get the graph of negative 2 to the x plus 1. So let's start with the graph of 2 to the x. So it go to 0, 1, 1, 2, 2, 4. And this is the graph of f of x equal 2 to the x. Okay. So g of x compared to the graph of f of x is shift up 1 unit and reflects across the y-axis. Okay. So shift up everything up 1 unit. Okay, up 1 unit, and then reflects it across the x-axis. Excuse me, across the y-axis. So this is the graph of f of g of x equal to negative 2x, negative 2 to the x plus 1. In the next problem, so we get the graph of f of x equal 2 to the x and g of x equal 3 to the 2 to the x on the same coordinate plane and compare them. Okay, so let's start with f of x equal 2 to the x. For g of x equal 3 times 2 to the x. So note that we take every point on the graph of f of x and we multiply it by 3. Okay. So start here with 0, 1, 1, 2, 2, 4. So at 0, g of x then equal 3. At 1, we get 6. And at 4, at x equal 2, 4 now become 12. Okay. So then this graph of g of x is gonna look like this. And again, we don't want it to cross the x-axis. So here g of x equal 3 times 2 to the x. So g of x, we had a vertical stress of factor of 3.